Hi everyone, welcome to CSIR Gold class. In this video, I am going to solve important second order kinetics numericals for CSIR NET, GATE and MSc exams. I will explain formulas, tricks, shortcuts also. After watching this video, you will be able to solve any second order problem confidently. Come, let's start. In my last video, I have explained these concepts and also formulas. Please watch that video once. Come, let's start with first question. If the rate constant for a second, if the rate constant for a base catalyzed ester hydrolysis reaction is 0.2 liter per mole per second, the half-life of the ester given. Here we have to find out half-life of the ester. Given ester naught is equal to base naught is equal to 0.05 per mole per liter. That would be closest to option is given as 40, 100, 140 and 200. In this question, they have asked base catalyzed ester hydrolysis. Base catalyzed ester hydrolysis is also called as second order reaction. Come, let's see the solution. For a second order reaction with equal initial concentrations, formula is T half is equal to 1 divided by Ka. In question, they have given rate constant K is equal to 0.2 liter per mole per second and initial concentration A is given as 0.05 per mole per liter. So T half is equal to 1 divided by 0.2 into 0.05. So D half is equal to 1 divided by 0.01. So answer will be 100 seconds. Option 2 is the correct answer. So here option 200 is the correct answer for this question. Now we'll see the key concept of this reaction. When second order reaction has equal initial concentrations, the half-life is T half is equal to 1 divided by K. Here K is rate constant and A is initial concentration. This is very important for second order reaction with equal initial concentrations. Next we'll see. This is the most repeated concepts. In last slide we have seen with the equal initial concentrations. Now we will see unequal initial concentrations. For a second order reaction, A plus B gives rise to product with A not equal to B naught. Sorry, here I have mentioned wrongly. This is A naught not equal to B naught. The half-life depends on what? Here options given as only K, only initial concentration, with K and initial concentration, temperature only. Actually, with unequal initial concentration, the half-life depends on both K and initial concentration. So answer C is the correct one. We'll go to next. Next is equal initial concentration. For a second order reaction, A plus B gives rise to product with A not equal to B not equal to 0. The half-life is solution. So for second order reaction with equal initial concentration, the formula is always T half is equal to 1 divided by Ka. So it is second order reaction. We'll see the next question. If the rate constant has units liter per mole per second, the reaction order is options given as for 0 order, first order, second order and third order. If you have seen liter per mole per second, it always belongs to second order. So second order is the correct option here. Next is which statement is correct for alkaline hydrolysis of ester? First order, first order, 0 order and second order overall. That alkaline hydrolysis of ester is always is equal to second order reaction. So option D is the correct one. We'll move to next one. For the second order reaction with K is equal to 0.5 liter per mole per second and A naught is equal to 0.2 molar. Calculate T half. See, for second order reaction, half life T half is equal to 1 divided by Ka. T half is equal to 1 divided by zero point 0.5 into zero point 0.2. So T half is equal to 105. So we'll move to next question. The correct integrated rate law for A plus B gives rise to products with equal concentration is, what is the integrated rate law equation for second order reaction? Formula is 1 divided by A is equal to 1 divided by A naught plus Kt. This is the important formula. Please remember this. Next is alkaline hydrolysis becomes pseudo first order when ester in excess, base in excess, equal concentration, temperature increase. In the base, if the base is excess, that then the alkaline hydrolysis becomes pseudo first order. So the option B is correct here, base in excess. Next we'll see the seventh question. The slope of straight line obtained by plotting 1 by A versus time equals initial concentration, rate constant, time and temperature. Here the slope, straight line. For the slope straight line for second order reaction 1 by A versus time, this will always equals to rate constant. So option B is the correct one. Next we'll see the eighth question. Actually this is one of the important question. Please remember this. Doubling both reactant concentrations in second order reaction changes half-life by options is 2 times, half times, 3 times and 4 times. We'll see the solution. For a second order reaction with equal initial concentrations, T half is equal to 1 by K. Here A is initial concentration, K is rate constant. If both reactant concentrations are doubled, A will becomes to 2 times of A. So T half is equal to 1 divided by K into A is 2A. So 1 by 2 into T half. So that answer will be half times. This is very important. Next is for a second order reaction with equal initial concentration, the unit of half-life is, if the second order reaction with the initial concentration, half-life unit is seconds. Half-life will be measured in seconds. Okay, thank you. If you found this video helpful, please like, share and subscribe. Comment if you want chemical kinetics other topics. Thank you for watching this.